cyanotype is a photographic printing process that produces a cyan-blue print. Engineers used the process well into the 20th century as a simple and low-cost process to produce copies of drawings, referred to as blueprints. The process uses two chemicals, ammonium ion, 3, citrate and potassium ferricyanide. History: the English scientist and astronomer Sir John Herschel discovered the procedure in 1842. Though the process was developed by Herschel, he considered it as mainly a means of reproducing notes and diagrams, as in blueprints. It was Anna Atkins who brought this to photography. She created a limited series of cyanotype books that documented ferns and other plant life from her extensive seaweed collection. Atkins placed specimens directly onto coated paper, allowing the action of light to create a silhouette effect. By using this photogram process, Anna Atkins is regarded as the first female photographer. Process: in a typical procedure, equal volumes of an 8.1% solution of potassium ferricyanide and a 20% solution of ferric ammonium citrate are mixed. This mildly photosensitive solution is then applied to a receptive surface and allowed to dry in a dark place. Cyanotypes can be printed on any surface capable of soaking up the iron solution. Although watercolor paper is a preferred medium, cotton, wool and even gelatin sizing on non-porous surfaces have been used. Care should be taken to avoid alkaline buffered papers, which degrade the image over time. A positive image can be produced by exposing it to a source of ultraviolet light through a contact negative. The UV light reduces the iron, 3, to iron, 2. This is followed by a complex reaction of the iron, 2, complex with ferricyanide. The result is an insoluble, blue dye known as Prussian blue. Exposure to ultraviolet light reduces the iron in the exposed, turning the paper a steel gray-blue color. The extent of color change depends on the amount of UV light, but acceptable results are usually obtained after 10–20-minute exposures on a dark, gloomy day. The highlight values should appear overexposed, as the water wash reduces the final print values. Prints can be made with large format negatives and lithography film, or everyday objects can be used to make photograms. After exposure, developing of the picture involves the yellow unreacted iron solution being rinsed off with running water. Although the blue color darkens upon drying, the effect can be accelerated by soaking the print in a 6% solution of 3% hydrogen peroxide. The water-soluble iron, 3, salts are washed away, while the non-water-soluble Prussian blue remains in the paper. This is what gives the picture its typical blue color. The overall contrast of the sensitizer solution can be increased with the addition of approximately 6 drops of 1% solution potassium dichromate for every 2 ml of sensitizer solution. Toning: in a cyanotype, a blue is usually the desired color. However, there are a variety of effects that can be achieved. These fall into 3 categories: reducing, intensifying, and toning. Reducing is the process of reducing or decreasing the intensity of the blue. Sodium carbonate, ammonia, Clorox, teaspoon, borax, Dektol and other chemicals can be used to do this. A good easily obtained reducer is bleach. Bleaching takes some patience. How much and how long you bleach depends on the image content, emulsion thickness and what kind of toning you're using. When using a reducer, it is important to pull the cyanotype out of the weak solution and put the cyanotype into a water bath to arrest the bleaching process. Intensifying is the strengthening of the blue effect. These chemicals can also be used to expedite the oxidation process the cyanotype undergoes. These chemicals are hydrogen peroxide, citric acid, lemon juice, and vinegar. Toning is the process used to change the color of the iron in the print cyanotype. The color change varies with the reagent used. There are a variety of elements that can be used, including tannic acid, oolong tea, wine, cat urine, and pyrogallic acid. Long-term preservation: in contrast to most historical and present-day processes, cyanotype prints do not react well to basic environments. As a result, it is not advised to store or present the print in chemically buffered museum board, as this makes the image fade. Another unusual characteristic of the cyanotype is its regenerative behavior, prints that have faded due to prolonged exposure to light can often be significantly restored to their original tone by simply temporarily storing them in a dark environment. Cyanotypes on cloth are permanent but must be washed by hand with non-phosphate soap so as to not turn the cyan to yellow. Largest cyanotype. The world's current largest cyanotype was created for World Cyanotype Day on September 19, 2015 in Johnson City, Texas, USA at Hill Country Science Mill. The cyanotype was organized by Shotapalooza, a photographic art collective, and was 30 feet by 90 feet in size. Many people laid on the cloth which was exposed to the sun for 10 minutes to make the image, and a fire truck was used to hose the work with water to fix it. Prior to this the record was set in Goa, India as part of the Story of Light Festival. Artists in residence Melanie King and Jaden Hastings created a 10-meter by 6-meter cyanotype using people, palm leaves and going Christ stars to create a pattern on cloth. See also. References, notes. Further reading, Atkins, Anna. Sun Gardens, Victorian Photograms. With text by Larry J. Scharf. New York, Aperture. ISBN 0-89381-203-X. Blacklow, Laura. New Dimensions in Photo Processes, A Step-by-Step Manual. Boston, Focal Press. ISBN 0-240-80431-7. Ware, M. Cyanotype, The History, Science and Art of Photographic Printing in Prussian Blue. Science Museum, UK ISBN 1-900747-07-3. Crawford, William. The Keepers of Light. New York, Morgan & Morgan. ISBN 0-87100-158-6. External links. Mike Ware's new cyanotype, a new version of the cyanotype that address some of the classical cyanotype's shortcomings as a photographic process. The largest cyanotype photograph, gallery of over 100 artists working in cyanotypes on alternativephotography.com, Brown, G. Ferric and heliographic processes. London. Photographic reproduction processes. A practical treatise of the photo impressions without silver salts. 1891.